the Younger Dryas impact. The world is ending, and no one knows why. One morning, roughly 12,800 years ago, the sky over North America lit up brighter than the sun. Not in one place, but everywhere at once, horizon to horizon, as if the atmosphere itself had been set on fire. Within hours, 35 species of large animals that had survived 3 ice ages simply ceased to exist. The most sophisticated culture on the continent vanished without a burial mound. And underneath it all, running through the rock on 4 continents simultaneously, a razor-thin black layer of charred earth, burned at temperatures no wildfire can reach. This is the Younger Dryas impact. And the most unsettling part isn't what it destroyed, it's what it didn't leave behind. In 2007, a team of 26 scientists, led by Richard Firestone of Lawrence Berkeley National Laboratory, published a paper in the Proceedings of the National Academy of Sciences identifying a carbon-rich black matte layer at 26 archaeological sites across North America. The layer contained nanodiamonds, cosmic impact spherules, iridium, and fullerenes, materials that form only under the extreme pressure and heat of a cosmic collision. The layer dated precisely to 10,900 BCE, the exact moment the Younger Dryas cold period began. A 1,200-year freeze that reset the climate of the entire northern hemisphere in what appears in the geological record to be almost no time at all. By 2018, the research team led by Christopher Moore had identified the same black matte layer at over 50 sites across North America, Europe, and the Middle East, all falling within the same 200-year window. Nanodiamonds of the type called landslide, which form only under hypervelocity cosmic impact conditions and do not occur naturally in the terrestrial environment, were found embedded in the layer at multiple independent sites. Platinum group element anomalies, including iridium concentrations far above background levels, mirror the chemical signature found at the Chicxulub boundary, the layer that marks the death of the dinosaurs. And ice core records from Greenland show a temperature drop of 15 degrees Celsius within decades at the Younger Dryas onset, faster than any climate shift recorded in the previous 100,000 years. The Clovis people disappeared at this exact layer, not in retreat, not in migration. They simply stop appearing in the archaeological record with no transition period, no trail of camps leading somewhere safer, no graves. 35 genera of large mammals, woolly mammoths, mastodons, American horses, giant ground sloths, short-faced bears, went extinct simultaneously at this boundary after surviving multiple previous glacial cycles. And in 2018, Moore's team found the impact layer at Abu Huraira in Syria, one of the earliest farming settlements ever discovered, buried under a 4-meter debris field consistent with an airburst event visible from the Middle East. The standard geological explanation is that the extinctions resulted from a combination of overhunting by human populations and the climate stress of the Younger Dryas cooling period. Many scientists accept the Younger Dryas impact hypothesis as a serious candidate while pointing out that no single confirmed crater has been found. Without a crater, some argue, there is no proof of a cosmic cause. The nanodiamond evidence has been challenged by researchers who suggest contamination or unusual geological processes could account for the concentrations. But overhunting doesn't burn the sky. It doesn't deposit nanodiamonds across 4 continents in the same stratigraphic layer. It doesn't end a climate period in decades when the previous interglacial had lasted thousands of years. And the absence of a crater isn't evidence against an impact. It may be evidence of something more interesting, a fragmented comet, a swarm of impactors hitting simultaneously across multiple continents, which would explain precisely why there is no single hole in the ground. Some researchers, including Graham Hancock in his 2019 work, argue the Younger Dryas event was not a strike, but a bombardment. And if it destroyed a civilization sophisticated enough to have settled 4 continents, the question isn't what killed them. The question is what they knew that we've been digging up ever since. There are no answers yet. Only the black layer running through the rock on 4 continents at precisely the same depth on precisely the same morning. Waiting. From the sky above North America, we descend to the volcanic heart of Southeast Asia, to a single mountain in Sumatra that may have reduced the entire human species to a group small enough to fit inside a modern sports stadium. The Toba supervolcano. Picture the human race reduced to a single, small town. Not a city, not a nation, a town. Somewhere between 3,000 and 10,000 people, scattered in isolated pockets across the African continent, clinging to survival in a world that has gone cold, gray, and silent. That is what happened. We know it happened because the evidence is written in your DNA. 74,000 years ago, a supervolcano beneath what is now Lake Toba in North Sumatra, Indonesia, detonated in the largest volcanic eruption of the last 2 million years. The numbers are difficult to hold in the mind. The eruption ejected approximately 2,800 cubic kilometers of magma, roughly 10,000 times the volume of the 1980 Mount St. Helens eruption. It deposited a 15-centimeter ash layer across all of South Asia. It covered a region roughly 1.5 times the size of North America in sulfuric acid aerosols, and it triggered a volcanic winter, estimated to have lasted 6 to 10 years, followed by a cold period persisting for roughly 1,000 years afterward. In 1998, anthropologist Stanley Ambrose of the University of Illinois published a landmark paper in the Journal of Human Evolution linking the Toba eruption directly to what he called the Toba catastrophe theory. By correlating genetic diversity data with the volcanic ash record, Ambrose proposed that the eruption caused a catastrophic population bottleneck, a near-extinction event in the global human population. The genetic evidence for this is not subtle. Mitochondrial DNA, inherited exclusively through the maternal line, shows an extreme narrowing of human genetic diversity consistent with the severe population bottleneck occurring approximately 70,000 to 75,000 years ago. Every human being alive today, all 8 billion of us, carries the compressed genetic legacy of a group that, by the numbers, may have been smaller than the population of a small modern suburb. Sulfur dioxide output from Toba is estimated at 6,000 billion kilograms. That is 100 times the total sulfur output of the 1991 Mount Pinatubo eruption, which by itself caused a measurable 0.5 degrees Celsius of global cooling. Global average temperatures in the immediate aftermath of Toba are estimated to have dropped by 3 to 5 degrees Celsius, with some models suggesting up to 15 degrees in higher latitudes, according to research by Rampino and self-published in 1992. The ash layer itself has been identified in marine sediment cores across the Indian Ocean, in ice cores from Greenland, and in terrestrial deposits stretching from India to East Africa, making Toba one of the most geographically traceable single volcanic events in Earth's history. A 2010 study by Michael Petraglia of the University of Cambridge found stone tools in Jwalapuram, India, both below and above the Toba ash layer, suggesting some human groups may have survived the eruption even in South Asia. And a 2018 study in Nature by Chris Clarkson and colleagues found evidence of continuous human occupation in South Africa through the Toba period, pointing to the African continent as the probable primary refuge for surviving populations. The mainstream scientific view accepts the Toba eruption as an extraordinary volcanic event, but is cautious about the catastrophe framing. A number of archaeologists argue the genetic bottleneck signal may predate Toba or reflect multiple smaller events rather than a single volcanic cause. They point to the Jualapuram tools and the South African sites as evidence of human resilience rather than near extinction, suggesting that whatever the population decline, it was never absolute. But resilience and near extinction are not mutually exclusive. Group of 10,000 people scattered across a continent is resilient in the sense that it survived. It is also, by any demographic measure, one bad hunting season from disappearing entirely. And the genetic signal doesn't resolve on a comfortable interpretation. It shows a compression so severe that the full diversity of modern humanity, every face, every language, every civilization that would ever exist, descended from a population that, at its lowest point, may have fit inside a village. Some researchers studying deep human lineage markers have proposed that the Toba bottleneck may explain something stranger still. Why did Homo sapiens, anatomically modern for at least 300,000 years, appear to behave like an entirely new species after 70,000 BCE? The explosion of symbolic culture, the rapid migration out of Africa, the sudden complexity of language and tool use, all of it appears in the archaeological record almost immediately after the bottleneck. As if the survivors didn't just endure the catastrophe, as if the catastrophe built something in them that hadn't been there before. We are, all of us, the children of that village, and we have no idea what was lost before it. From the volcanic depths of Sumatra, we travel northwest to the floor of the Norwegian Sea, where a catastrophe far more recent and far more personal may have swallowed an entire inhabited world within living human memory. The Storegga landslide. 8,000 years ago, Britain was not an island. You could walk from what is now London to what is now Amsterdam across a low, fertile plain teeming with red deer, wild aurochs, and Mesolithic hunters. Rivers crossed it, communities settled it, people were born on it, lived their whole lives on it, and were buried in its soil. That world had a name given to it by modern researchers. They called it Doggerland, and it ended in a single morning. Not slowly, not across generations, in hours. Beneath the Norwegian Sea, a section of the continental shelf had been accumulating sediment for thousands of years. It was stable, ancient, and enormous, 290 kilometers wide, covering an area of 95,000 square kilometers, roughly the size of Iceland. And then, approximately 8,100 years ago, it moved. The entire section sheared away from the seafloor and collapsed into the deep ocean in what may have been minutes. 3,500 cubic kilometers of sediment hit the abyss. The water above it had nowhere to go but outward. And outward, at that moment, meant towards Scotland, Norway, the Faroe Islands, and the low-lying shores of Doggerland. The Storegga slides were first identified through sediment core analysis in the 1970s and 80s by Norwegian petroleum geologists mapping the seafloor. Definitive dating was achieved and published by Bondevik and colleagues in 2005 in Quaternary Science Reviews, which established the event date at approximately 6,100 BCE and calculated wave heights of 10 to 25 meters striking the Scottish coastline. In over 30 confirmed locations along the Scottish and Norwegian coasts and the Faroe Islands, geologists have found the same distinctive sand layer sitting between undisturbed layers of normal peat, a deposit interpretable only as a single catastrophic marine inundation. The layer is consistent. The radiocarbon dates converge. The event happened. In the Montrose Basin and other funnel-shaped Scottish inlets, wave height reconstructions placed the incoming wall of water at a confirmed 25 meters. That is roughly the height of an 8-story building, arriving from the sea with no warning, no precedent, and no explanation available to anyone standing on the shore. Archaeological evidence from Inverness confirms that Mesolithic occupation sites lie directly below the Storegga tsunami deposit, meaning people were living in the inundation zone when it hit. The trigger mechanism is believed to be the destabilization of methane hydrates, frozen gas deposits locked in the seafloor sediment, gradually released as ocean temperatures rose at the end of the last glacial period. A mechanism that, it should be noted, may be reactivating in warming Arctic waters today. Doggerland had already been shrinking. Post-glacial sea level rise had been slowly inundating its lower margins for centuries. But a 2020 study modeling the final inundation suggests the Storegga tsunami delivered the decisive blow, permanently severing Britain from the European continent and submerging a landmass inhabited by a Mesolithic population estimated at several thousand people. A seismic scar 290 kilometers wide still marks the Norwegian seafloor, visible today in bathymetric surveys as one of the largest submarine landslide features on Earth. The mainstream geological view accepts all of this. The Storegga event is well documented. The debate concerns its human significance. Many archaeologists argue the flooding was incremental enough that most coastal inhabitants could have retreated over days or weeks as the water advanced. The population of Doggerland was likely sparse, they suggest, and the loss, though real, was not civilization ending. But 15 centimeters per day sounds gradual only in abstract calculation. Measure it across a month, and the water has risen 4.5 meters. The fields your family farmed, the estuary where you fished, the graves of your grandparents, gone permanently under salt water that never recedes. There is no drought that ends. There is no season that brings the land back. Whatever people lived on Doggerland shores when the wave hit, they carried something with them when they ran. Something that turned out to be more durable than stone walls or burial mounds. Researchers, including archaeologist Brian Coles, have pointed to an intriguing pattern. The Celtic legendary traditions of Atlantic coastal peoples, the sunken kingdom of Lyonesse off Cornwall, the drowned land of Ise off Brittany, the lost realm of Contrir Gwaelod in Wales, all describe fertile lowlands swallowed by the sea within human memory. They were written off as myth for centuries, but every single one of them points geographically toward the North Sea, and the North Sea floor has now confirmed in sediment and in scar that exactly that story is true. The memory survived. We just stopped believing it. From the seabed off Norway, we move now to an event with no visible wound and no recoverable coastline. An event that shut down the engine of the entire global ocean and whose fingerprints may be buried inside the oldest flood stories ever written. The 8.2 kilo-year event. Imagine the ocean stops working. Not the surface, the waves keep coming. The deep ocean. The invisible planetary conveyor belt that carries warm tropical water north, sinks it as it cools, and recycles cold bottom water south. The system that keeps northern Europe from freezing. The system that delivers monsoon rains to the Sahel. The system that regulates the temperature of every coastline on Earth. Now imagine it stutters, slows, nearly stops. That is exactly what happened 8,200 years ago. And it lasted 160 years. The event was first identified in Greenland ice core records by Alley and colleagues in their 1997 paper in Geology. The GISP2 and GRIP ice cores, two of the most detailed climate archives ever extracted from the ice, both show the same abrupt signal. A temperature anomaly of 3 to 8 degrees Celsius appearing suddenly, persisting for approximately 160 years and then ending almost as abruptly as it began. It is the largest, sharpest climate disruption of the entire Holocene. The 11,700-year warm period in which every human civilization ever built has existed. The cause was identified by Clark and colleagues in 2004 in Nature. Glacial lakes Agassiz and Ojibwe, two colossal bodies of meltwater trapped behind deteriorating ice dams in what is now central Canada, had been growing for thousands of years. When the dam finally gave way, an estimated 163,000 cubic kilometers of cold fresh water, a volume equivalent to several times the entire modern Caspian Sea, poured into the Labrador Sea in what may have been less than a year. This pulse of cold, fresh water was sufficient to dilute the North Atlantic salinity, reduce its density, and slow the Atlantic meridional overturning circulation, the ocean conveyor belt, to near stasis. The climate consequences rippled outward across the entire planet within years. Greenland ice cores record the temperature crash. Speleothem records from cave stalagmites in China, Turkey, and the Arabian Peninsula independently confirm the cold and dry anomaly. Pollen records from the Middle East, Northern Europe, and West Africa show simultaneous vegetation stress. Marine sediment cores from the North Atlantic show changes in planktonic assemblages consistent with dramatic surface freshening. The signal appears in every proxy, on every continent, at the same time. This was not a regional event, it was a planetary one, and then there is the human timing. The earliest known farming settlements in the Fertile Crescent, sites in modern Turkey, Syria, and Iraq that represent the first serious attempts at organized agriculture in human history, show evidence of abandonment or population stress precisely within the 8.2 kiloyear window, according to a 2006 study by Wenninger and colleagues published in Documenta Prehistorica. Communities that had been slowly building the infrastructure of civilization appear in the archaeological record of this period to simply scatter. The mainstream interpretation is careful. The cold period was temporary, lasting roughly 150 to 160 years before the overturning circulation recovered. The connection between the climate event and the disruption of early farming communities is considered correlational by many archaeologists who note that settlement abandonment had multiple potential causes and that the evidence for direct causation is indirect. But 160 years of cold, unreliable climate falling on people who had barely invented agriculture is not a footnote. It is 6 to 8 complete human generations, every one of whom would have experienced crop failure, failed seasons, and the inexplicable hostility of a world that had, until recently, been growing warmer and more generous. And there is something arresting about what happens immediately after the event ends. The overturning circulation recovers, the climate stabilizes, and within a few centuries, the first proto-cities appear in Mesopotamia, precisely in the region whose early farming communities the 8.2 kiloyear event had disrupted. William Ryan and Walter Pittman of Columbia University, whose work on the Black Sea flood we will return to, suggested that the sea level rise associated with the 8.2 kiloyear meltwater pulse may have contributed to the catastrophic inundation of the Black Sea basin, potentially the historical event encoded in the flood myths of Mesopotamia, the oldest written versions of which originate in the exact geographic region that would have been affected. If so, the 8.2 kiloyear event didn't just disrupt the first farmers, it may have simultaneously created the sea that swallowed their homeland, and it may have given them the story they never stopped telling. From a planetary ocean engine that nearly stopped, we travel now to something even more fundamental: the invisible armor that stands between every living thing on Earth and the radiation of deep space. And the 2,000-year window when that armor nearly disappeared entirely. The Laschamp geomagnetic excursion, Strip the sky of everything invisible that protects you. Not the atmosphere. That stays. The magnetic field. The invisible shell of force generated by Earth's liquid iron core extending tens of thousands of kilometers into space, deflecting the solar wind, bending cosmic rays away from the surface. The only thing standing between you and a constant barrage of radiation energetic enough to damage DNA, deplete the ozone layer, and raise cancer rates across every exposed ecosystem on the planet. 41,000 years ago, that shield didn't just weaken, it nearly vanished. And when it did, the oldest human species on Earth disappeared with it. The Laschamp excursion, a near reversal of Earth's magnetic poles, was first identified in lava samples from the Auvergne region of France in the 1960s. The rocks showed reversed magnetic polarity, meaning they solidified when Earth's field was oriented opposite to today. But the full picture of what that meant for life on the surface wasn't assembled until 2021, when a team led by Alan Cooper published a landmark study in Science using a 50,000-year climate record extracted from stalagmites in Hulu Cave, China. The result was the most detailed portrait ever assembled of what happens to Earth when its magnetic field collapses. During the Laschamp excursion, Earth's magnetic field dropped to approximately 5 to 6% of its current strength. The full collapse lasted roughly 2,000 years, with the period of extreme weakness centered on 41,000 BCE. During this window, the production rate of cosmogenic isotopes, beryllium-10 and chlorine-36, elements generated when cosmic rays strike the upper atmosphere, reached the highest levels recorded anywhere in the 50,000-year ice core record. Those production rates are a direct measure of how much radiation was penetrating the atmosphere. The numbers indicate that cosmic ray flux at Earth's surface during Laschamp was 2 to 3 times its normal level. The ozone layer was significantly depleted, and auroras, the northern lights, would have been visible continuously at equatorial latitudes. A relentless atmospheric spectacle witnessed by populations who had no framework for understanding what they were seeing. The last confirmed evidence of Neanderthal occupation in Europe dates to approximately 40,000 to 39,000 BCE. That places the Neanderthal extinction within 1,000 to 2,000 years of the Laschamp intensity minimum. Neanderthals had survived in Europe for at least 300,000 years. They had endured multiple glacial maxima, volcanic winters, sea level changes, and competition with other archaic human lineages. They made ornaments. They buried their dead. Recent genetic analysis has confirmed that they interbred successfully with Homo sapiens, and roughly 2% of the DNA of every non-African person alive today is Neanderthal in origin. These were not fragile creatures. Something unusual happened at 41,000 BCE. The Cooper team's 2021 paper proposes a direct causal link. The magnetic field collapse would have produced prolonged disruption of global atmospheric circulation patterns, driving climate instability on top of an already cold glacial period. Megafaunal extinction data analyzed by Lorenzen and colleagues in their 2011 Nature study shows elevated species loss in European mammals in the 40,000 to 35,000 BCE window, a signal that cannot be cleanly separated from either the Laschamp event or the simultaneous arrival of Homo sapiens. The two pressures overlapped, and Neanderthals, who had been weakened by millennia of fragmented small group survival, may simply have had no margin left. The mainstream view in paleoanthropology favors a multi-causal model. Competition with Homo sapiens, climate stress, and habitat fragmentation all contributed to Neanderthal disappearance in this reading, with the magnetic excursion as one pressure among many. The Cooper paper, while widely covered, has not become consensus, but multi-causal models have a way of making everything seem inevitable in retrospect. Neanderthals survived every glacial maximum for 300,000 years. What was different at 41,000 BCE? The magnetic record shows exactly one thing that was different, and the timing is not approximate, it is precise. There is a detail in the Laschamp data that tends to go unreported. Earth's magnetic field has been weakening at a measurable rate since at least 1840. The South Atlantic anomaly, a region of already depleted magnetic field intensity over the South Atlantic, has been growing measurably for decades. Some geophysicists consider it a potential early marker of a future excursion. The Laschamp record is not only history, it may be a preview. From the collapse of the magnetic sky, we descend now in time by an almost incomprehensible distance, 2.5 billion years, to the catastrophe that was caused not by a rock from space, not by a volcano, not by a collapsing glacier, but by life itself. A single organism operating through pure biological mechanics that turned the atmosphere of the entire planet into poison. The Great Oxygenation Event. Imagine an organism so successful, so unstoppably prolific, that its waste product, the chemical byproduct of its metabolism, becomes so concentrated in the atmosphere that it kills nearly every living thing on Earth. That organism exists. It is still alive. You can find it in any pond, any puddle, any sunlit ocean surface on the planet. And the poison it releases, the substance that allowed every animal, every plant, every complex living thing to eventually exist, is the air you are breathing right now. 2.4 billion years ago, Earth's atmosphere contained virtually no free oxygen. Life had existed for at least 1 billion years in an anaerobic world, a world dominated by microorganisms that metabolized sulfur, iron, and carbon dioxide, and that were most of them acutely sensitive to oxidizing chemistry. Oxygen, in sufficient concentration, corrodes cellular machinery. It generates free radicals. It is, to an organism evolved without it, a slow and systemic poison. And then cyanobacteria began producing it, not in response to any selective pressure toward oxygen generation, as a byproduct of photosynthesis, of splitting water molecules to harvest hydrogen for energy and releasing the oxygen as waste. As their populations expanded across the global ocean's sunlit surface over millions of years, oxygen concentrations in the atmosphere crossed a threshold. The anaerobic world didn't adapt. It died. The event is called the Great Oxygenation Event, or the GOE, and its timing is recorded in the rock with extraordinary clarity. Researchers including Preston Cloud in the 1960s and 70s, and later geochemist James Farquhar and colleagues in their 2000 paper in Science, identified the chemical signature, the disappearance of mass-independent fractionation of sulfur isotopes in the geological record at approximately 2.4 billion years ago. This particular chemical pattern can only form in an oxygen-free atmosphere. Its abrupt disappearance is a direct timestamp, the moment Earth's air became permanently oxidizing. Banded iron formations tell the same story. These alternating layers of iron oxide and silica, found in ancient rock sequences across Australia, Canada, and South Africa, including the massive deposits of the Pilbara and the Hamersley Basin, record the progressive oxidation of dissolved iron in the ancient ocean as atmospheric oxygen levels rose. They stopped forming after the GOE because the dissolved iron had all been oxidized. The oceans had been transformed from chemistry to chemistry, from top to bottom, permanently by a microorganism that had no idea it was doing it. The estimated scale of the anaerobic extinction is difficult to quantify because it left no bodies, no bones, no shells, no identifiable megafauna. But by the measure of total biomass and species diversity, the organisms killed or displaced by the GOE were almost certainly the dominant life forms on Earth at the time. The entire pre-oxygen biosphere, 2 billion years of evolution, was replaced. And the GOE triggered something else, the Huronian glaciation, one of the longest ice ages in Earth's history, lasting approximately 300 million years. The proposed mechanism is straightforward and alarming. Oxygen reacted with methane in the atmosphere, methane that had been acting as a greenhouse gas, keeping the planet warm. As the methane was destroyed, the greenhouse effect collapsed. Earth froze. The mainstream scientific view treats the GOE as the essential precondition for all complex life. Without it, no animals, no plants, no us. In this framing, it was not merely a disaster, but the necessary engine of everything that followed. A catastrophe that created a new world far richer than the one it ended. But necessary precondition is a perspective only available to the organisms that benefited from it. From the perspective of the anaerobic world it erased, the GOE was a total extinction, not caused by an impact from space, not by a volcanic eruption, but by the unchecked metabolic success of a competitor. It is the only confirmed case in Earth's 4.5 billion year history where life itself, operating through ordinary biology, destroyed its own world and replaced it with a different one. And it happened once. Some astrobiologists at institutions including NASA's Astrobiology Institute use it as the primary model for understanding what life does to a planet once it arrives. Not whether a planet has life, but what a planet becomes because of it. The question that lingers and that has never been fully answered is whether once is the rule, or whether the pattern is older than we think. From the microorganism that poisoned a world, we travel forward 2 billion years, to the event that came closest of all to finishing the job, the Great Dying. There is a number that should stop you cold, 96%. That is the fraction of all marine species erased from existence in what the fossil record calls the Permian-Triassic extinction. Not most life, not half, 96%. The oceans, alive with complex ecosystems for hundreds of millions of years, were reduced to near sterility. On land, 70% of all vertebrate species died. It is not called a mass extinction. Scientists call it the Great Dying, and new precision dating suggests it may have happened in less than 60,000 years, possibly in 20,000. On geological timescales, that is not a slow extinction. It is a door slamming shut. The cause is written in the rock of Siberia. The Siberian Traps, a large igneous province covering approximately 2 million square kilometers of what is now northern Russia, erupted in the largest volcanic episode of the last 500 million years. Precision uranium-lead zircon, dating by Seth Burgess of the United States Geological Survey and colleagues, published in the Proceedings of the National Academy of Sciences in 2014, places the peak volcanic activity at 252.28 million years ago, plus or minus 0.08 million years. That date is statistically indistinguishable from the Permian-Triassic extinction boundary, one of the tightest causal links ever established in the entire extinction record. The eruptions produced an estimated 3 million cubic kilometers of basalt lava. To put that in terms that hold meaning, enough to cover the entire contiguous United States in a layer 400 meters deep. But the lava itself was not the primary kill mechanism. As the eruptions burned through the enormous coal deposits and salt beds underlying Siberia, they released catastrophic quantities of carbon dioxide, methane, and sulfur dioxide directly into the atmosphere, ocean temperatures in tropical zones rose to an estimated 36 to 40 degrees Celsius, near or beyond the thermal tolerance of most marine organisms, according to research by Sun and colleagues published in Science in 2012. Isotopic analysis of carbon-13 in marine sediments shows a sudden, massive negative excursion at the boundary, consistent with the rapid injection of billions of tons of isotopically light carbon into the atmosphere from volcanic methane and burning coal beds, documented by Thao and colleagues in 2009. The oceans acidified. The calcium carbonate that shellfish and corals use to build their bodies dissolved. Bottom waters lost their oxygen. Hydrogen sulfide, lethal even in small concentrations, may have been produced by anaerobic bacteria in the suffocating depths and released into the atmosphere itself. Earth ran every extinction mechanism simultaneously at planetary scale for tens of thousands of years. Recovery was extraordinarily slow. Ecosystems did not return to pre-extinction complexity for approximately 10 million years, far longer than after any other known mass extinction. The coal gap tells the story plainly. For roughly 10 million years after the Permian-Triassic boundary, there are almost no coal deposits anywhere on Earth because coal forms from compressed plant material, and for 10 million years, there were not enough forests to make it. Land plant communities were so devastated that forests effectively stopped existing. A study by Svensson and colleagues in 2009 estimated that the Siberian Trap's eruptions may have burned through approximately 6.5 trillion tons of organic material in the underlying sedimentary rock, potentially releasing more greenhouse gas in 100,000 years than would be produced by burning all of Earth's current fossil fuel reserves many times over. The mainstream scientific view attributes the Great Dying to the Siberian Trap's volcanism, with broad consensus on the basic kill mechanisms. The debate within the field concerns relative contributions: how much was acidification, how much was warming, how much was anoxia, and the precise duration of the main extinction pulse. But the number that resists any comfortable framing is not the kill fraction. It's the recovery time. 10 million years. If the Great Dying had been only marginally more severe, if the few surviving lineages of marine invertebrates and land vertebrates had not held on, there would have been no dinosaurs, no mammals, no pathway to anything that followed. The margin between the world we live in and a permanently sterile planet was not wide, and the mechanisms that drove it, warming oceans, acidification, anoxia, methane release, are not historically sealed. They are physical and chemical processes that respond to inputs. Some researchers studying the Great Dying as a climate analog have noted that the rate of carbon injection during the Siberian Trap's eruptions, while vastly larger in total volume, was slower per year than the current rate of human carbon emissions. This observation has appeared in peer-reviewed literature, not as rhetoric, but as a quantitative comparison. The planet has survived the Great Dying once. It did not survive it easily, and it did not survive it quickly. It survived it by the thinnest possible biological margin. From the event that nearly ended all complex life on Earth, we travel now to a catastrophe quieter in its mechanism, but almost as consequential in its reach. A disaster caused not by fire or asteroid, but by a tree. The late Devonian extinction. The trees did it, not a meteor, not a volcano, not a gamma ray burst from a dying star, though that theory also exists for this period and has not been ruled out. The second largest mass extinction in Earth's history, an event that killed 75% of all species on the planet, may have been triggered by the first forests. Trees evolved deep roots, cracked rock, and released a geochemical cascade so powerful it stripped oxygen from the oceans of the entire world. 385 million years ago, something unprecedented happened on Earth's continents. Trees evolved, not shrubs, not ferns. Trees, tall, woody, with root systems that penetrated rock meters below the surface, fracturing mineral substrates that shallow plants had never touched. As those roots broke down silicate rocks, they released massive quantities of phosphorus and nitrogen, the fundamental nutrients of biological growth, directly into river systems. The rivers carried the nutrients to the shallow tropical seas, and in those seas, the algae bloomed. This is the hypothesis developed by paleontologist Thomas Algeo and paleobotanist Stephen Scheckler of Virginia Polytechnic Institute, published in their 1998 paper in Philosophical Transactions of the Royal Society B. It is called the terrestrial-marine teleconnection hypothesis, and it describes a chain of causation that stretches from a forest floor to the bottom of a suffocating ocean. As the algal blooms died and decomposed, bacteria consumed the dissolved oxygen in the water. The process is called eutrophication, and in the Devonian seas it ran out of control. Not in one ocean. In all of them, over and over, in pulses spanning 25 million years, until 75% of all species on Earth were gone. The evidence is written in black shale. These sedimentary rocks, formed in oxygen-depleted bottom waters, are found globally in late Devonian deposits across North America, Europe, and North Africa, and they contain molecular biomarkers indicating widespread hydrogen sulfide production in the deep ocean. Phosphorus concentration anomalies in late Devonian marine rocks have been independently measured by multiple research groups and show values significantly above background levels during extinction intervals consistent with the land-derived nutrient flooding proposed by Algeo and Scheckler. And the Devonian reef system, the second largest in Earth's history, stretching across the tropics for tens of thousands of kilometers, disappeared almost entirely. According to research by Copper published in 1994, coral reefs did not substantially recover for approximately 100 million years. 100 million years. A competing hypothesis, proposed by Mellott and colleagues in 2004 in the International Journal of Astrobiology, suggests that a gamma ray burst from a hypernova within 6,000 light-years of Earth may have provided the initial extinction trigger by stripping the ozone layer globally. This remains controversial, but has not been definitively refuted. The two mechanisms are not mutually exclusive. A radiation event could have initiated the collapse that terrestrial eutrophication then sustained across millions of years of pulses. The Hangenberg event, the final and most acute pulse of the late Devonian extinction at approximately 359 million years ago, eliminated virtually all the placoderms, armored fish that had dominated Earth's oceans for 70 million years. Their extinction opened the ecological space eventually filled by sharks and bony fish, the ancestors of every vertebrate alive today, including every human being who has ever lived. The mainstream view treats the late Devonian as a genuinely multi-causal event. Sea level changes, volcanism, and possible extraterrestrial influences all contributing alongside the terrestrial vegetation hypothesis. Most researchers emphasize that it was a protracted series of extinction pulses rather than a single catastrophe, and the Algeo-Scheckler model, while well evidenced, explains the anoxic pulses without fully accounting for the complete extinction pattern. But the core of the tree hypothesis is extraordinary in a way that deserves to stand alone for a moment. This was not a random catastrophe. It was not a rock from space or a random volcanic eruption. It was the natural, ordinary operation of biology. The evolution of deep roots, the chemical weathering of rock, the delivery of nutrients to coastal seas, producing, entirely without intent, a cascade that killed 3/4 of life on Earth. the most consequential act of biological engineering in the history of complex life, performed by a tree that had no idea it was doing it. From a forest that ended a world, we move now to a sea that erased itself. One of the strangest transformations in the geological record, and almost entirely unknown outside the specialist literature that documented it. The Messinian salinity crisis. The Mediterranean Sea evaporated. Not once, not partially. It dried up almost entirely, leaving a desert basin 3 to 5 kilometers below sea level, encrusted in salt, baked under a sun fiercer than anything the Sahara experiences today. The rivers of Europe, ancestors of the Nile, the Rhone, the Abro, carved canyons deeper than the Grand Canyon, racing toward a basin that was falling away below them. Then millions of years later, the Atlantic came back. And when it did, it didn't trickle in. It fell. The evidence for this begins not with a dramatic discovery, but with a routine one. In the 1950s and 60s, engineers drilling beneath the Nile Delta for the Aswan Dam project encountered something that made no sense. Below the sediment, the rock dropped away. A buried canyon extending 1,200 kilometers from southern Egypt to the delta, descending to approximately 2,500 meters below present sea level. That is deeper than the Grand Canyon. It was carved by a river falling toward a sea surface far below where the Mediterranean sits today. Kenneth Shue of the Lamont Doherty Earth Observatory, who investigated the anomaly with William Ryan, later described the moment in his 1983 book, The Mediterranean Was a Desert. The canyon wasn't the anomaly, it was the confirmation. The Nile had been carving downward toward an almost empty basin. In 1970, the deep-sea drilling project confirmed what Howe and Ryan suspected. Core samples taken from beneath the Mediterranean seafloor contained halite, rock salt, and anhydrite layers up to 3 kilometers thick. These evaporate deposits form only under conditions of extreme desiccation, when a body of water is reduced to near nothing, and its dissolved minerals are left behind as the water evaporates. The event is dated to 5.96 to 5.33 million years ago by Kriegsmann and colleagues using magnetostratigraphy and biostratigraphy of marine sediments. It lasted approximately 630,000 years. The total salt deposited is estimated at 1 million cubic kilometers, enough to cover the entire contiguous United States in a layer of salt 130 meters deep. Temperature and aridity models for the basin during desiccation suggest surface conditions in the deepest subbasins would have exceeded 80 degrees Celsius in summer, an environment more hostile than almost anywhere on the planet's current surface. Similar buried canyon structures have been identified for the Rhone beneath the Rhone Delta and for the Ebro, confirming that every major river draining into the Mediterranean was cascading toward a basin dramatically below current sea level. The basin's removal of water, roughly 6% of the entire world ocean, raised global salinity measurably and lowered global sea level by an estimated 8 to 12 meters. The refilling event, known as the Zanclean flood, was modeled in detail by Garcia Castellanos and colleagues in their 2009 Nature paper. Their model calculates peak water discharge through the breached Gibraltar sill at up to 100 million cubic meters per second, with Mediterranean sea level rising by potentially several meters per day during the peak inflow, and the basin possibly refilling in anywhere from months to a few thousand years, depending on the breach geometry. This would make the Zanclean flood the largest documented flood event in Earth's geological record, a wall of Atlantic water pouring through the Gibraltar Gap, falling into a desert kilometers below sea level, carving a channel wider and deeper than anything produced by any river in Earth's history. The mainstream geological view accepts the Messinian salinity crisis as well documented. The debate concerns the mode of the Zanclean refilling, whether it was catastrophic, as Garcia Castellanos models, or gradual and sustained over thousands of years. Some researchers favor a slower refilling sequence, arguing the geological evidence for extreme peak discharge is ambiguous, but even the conservative version is staggering. This is not a lake drying up. This is the near-total evaporation of an inland sea covering 2.5 million square kilometers, repeatedly over more than 500,000 years. The planet's own tectonics sealed a basin the size of southern Europe, baked it, salted it, and then breached it. And the breach, when it came, was almost certainly the most violent hydrological event in the history of any ocean on this planet. Somewhere at the bottom of the Mediterranean, under kilometers of sediment, the scars of that refilling are preserved. We know they are there. We have not yet fully read what they say. From the sea that disappeared, we arrive at our final entry, smaller in geological scale than anything that preceded it, but the most human of all the catastrophes on this list, the one that happened to people we can almost remember, the one whose survivors built the first cities, and the one that may have first taught our species the word for the end of the world. The Black Sea Flood. Every culture on Earth has a flood story. The Sumerians, the Hebrews, the Greeks, the Hindus, the Aztecs, the Aboriginal Australians. For 2 centuries, historians called this a coincidence, a universal myth born from universal human fears of water and chaos. But in 1997, 2 Columbia University oceanographers dragged a sediment core from the floor of the Black Sea, and the coincidence became a crime scene. The flood story isn't a myth, it's a memory, and we can date the memory to within a human lifetime. Before approximately 5,600 BCE, the Black Sea was a freshwater lake, significantly smaller than it is today, sitting well below the level of the Mediterranean, its shores settled by Neolithic farming communities who had found the fertile lake margins among the most productive agricultural land in the ancient world. The Mediterranean, meanwhile, had been rising for thousands of years as the last glaciers melted and poured their water into the world ocean. At some point, the rising water reached the Bosphorus, then a narrow land bridge of perhaps only a few meters of elevation separating 2 bodies of water at dramatically different levels. When it broke, the Mediterranean didn't flow in, it fell. William Ryan and Walter Pittman of the Lamont Doherty Earth Observatory published the Black Sea Flood Hypothesis in 1997 in Marine Geology, then expanded it in their 1998 book, Noah's Flood, the new scientific discoveries about the event that changed history. The evidence they found is not speculative. Sediment cores from the Black Sea floor show a sharp transition from freshwater lacustrine sediment to marine sediment at a depth corresponding to approximately 7,600 years before present. The transition layer contains a thin band of mixed freshwater and marine shells, the signature of a rapid salinity change. Below it, freshwater. Above it, salt. The line between the two is not gradual. It is a boundary. The pre-flood shoreline of the Black Sea Lake lies approximately 170 meters below the current sea level. This is confirmed by sonar mapping of the Black Sea floor, which reveals ancient river channels, beaches, and shallow water sedimentary structures on what is now deep sea floor. Ryan and Pittman's hydrological model calculates the inflow rate through the Bosphorus breach at approximately 50 cubic kilometers per day, sufficient to raise the Black Sea level by roughly 15 centimeters per day. In 2000, oceanographer Robert Ballard, who had located the wreck of the Titanic, led an expedition to the Black Sea and announced the discovery of an ancient coastline at 155 meters depth, along with what appeared to be tool-worked wood and other possible human artifacts at that depth. The confirmation of those artifacts' human origin has remained debated, but the ancient coastline itself is not in dispute. The flooding submerged approximately 155,000 square kilometers of land, an area larger than England and Wales combined. Ryan and Pittman estimated the displacement of perhaps 100,000 people within a generation. Ancient DNA studies published in Nature in 2015 by Hawk and colleagues identified a genetically distinct Neolithic farming population originating near the Black Sea region that dispersed rapidly across Europe and the Middle East in the centuries following approximately 5,600 BCE, a migration pattern consistent with large-scale forced displacement from a flooded homeland. The Epic of Gilgamesh, written on clay tablets in Mesopotamia approximately 2,700 BCE, but based on oral traditions substantially older, describes a flood in which Utnapishtim is warned by a god to build a boat and save his family and animals. Birds are sent out to find land. The vessel comes to rest on a mountain peak. The specific details appear in over 200 independently recorded flood myths across cultures that, according to the conventional timeline of history, had no contact with one another. The mainstream view accepts the Black Sea flood as a geological event but is cautious about its mythological significance. Many archaeologists argue the flooding was too gradual to constitute the sudden catastrophe the myths describe, and that the population displaced was too sparse for the event to have generated a globally transmitted narrative. The flood myth in this reading is a convergent cultural product. Every human civilization near water eventually invents one. But 15 centimeters per day is not gradual when it never stops. Measure it across a year and the water has risen 55 meters. The fields where you planted your first crops, the graves of your grandparents, the settlement your community had built over generations, all of it permanently under salt water. There is no season that brings it back. And the survivors carried something with them when they fled. A story exact in its details, consistent in its geography, persistent across 7,600 years of retelling, embedded in the oldest written literature ever found, translated into hundreds of languages by peoples who had never met. Some things are too specific to be coincidence. Some stories are too old to be invention. The Black Sea flood didn't just drown a shoreline. It may have been the first catastrophe that humanity decided it could not afford to forget. 10 disasters, 10 resets, and across all of them, the same pattern refuses to resolve into comfort. The mainstream scientific position on each of these events is reasonable, carefully evidenced, and in most cases broadly correct about the mechanisms involved. Impacts happen. Supervolcanoes erupt. Ocean circulation stutters. Magnetic fields collapse. Microorganisms alter atmospheres. Forests acidify oceans. Seas evaporate. Dams break. The physical causes are understood, at least in their broad outlines. What the standard framing is slower to confront is what the sequence implies. Not the individual events, but the aggregate. That this planet has been catastrophically resetting itself since life first appeared on it, that the resets are not aberrations but recurring features of an active planetary system, and that the window of stability in which all human civilization has existed is not the default state of this world. It is the exception. The alternative interpretation running through all 10 of these events is not a conspiracy. It is a scale problem. Human cognition is built for decades, not millions of years. We perceive stability because we live within a moment of it, and we build our institutions, our assumptions, and our confidence on the ground beneath our feet as if it will always hold. Every item on this list is a document from a previous moment of stability that ended. Suddenly, in geological terms. Without warning, for the organisms that lived through it. and with no regard for the complexity of what it destroyed. What connects all 10 is not mystery, it is pattern. And the pattern is not reassuring, unless you account for the other half of the story. 96% of marine life died in the Great Dying. The 4% that survived became every complex animal that ever lived. The entire human species compressed to a town of 10,000 and expanded to 8 billion. A continent was swallowed by the sea, and the survivors built civilization from the ruins. The pattern is not only catastrophe, it is catastrophe followed eventually by something that never existed before. Most people will encounter one or two of these events in a textbook, accept the explanation offered, and move on. You made it here. That is not a small distinction. It means your instinct is to stay with the discomfort rather than resolve it prematurely. To hold the scale of what you're looking at long enough to actually see it. That is the specific habit of mind this subject rewards. And it is why you're here and why we keep going. Subscribe so you don't miss what we excavate next. And go to the comments right now. Tell us which of these 10 events you think left the deepest mark on human memory and which one you think we are least prepared to face again. Defend your answer. The floor is yours. 10 resets. 10 times the planet unmade itself and started over. And 10 times something in the wreckage held on long enough to become the next chapter. The younger Dryas wiped a sky clean. The Black Sea carved a story into human memory so deep it survived 7,000 years of retelling. What connects them is not darkness. It is the stubborn, improbable fact of continuation. We are not here because this planet is safe. We are here because something always survives, and survival, given enough time, becomes everything. The real question isn't whether the next reset is coming. The question is what will carry through it. Subscribe, and don't stop asking why.